Okay, what we're going to start in Chapter 1 is talking about limits, and you really haven't talked about limits at all in pre-calc, so this is going to kind of be new stuff to you. I don't think it's going to be terribly difficult. It's just kind of understanding what a limit is and what I'm talking about. So when I refer to a limit, basically a limit, and this is, you'll see in example 1, this is how we write a limit. So it says LIM means the limit, and it's the limit as x is approaching some number. And they're always going to tell you, I want to know what is the limit as x is approaching 0 or -8 or 2 or something. So they're always going to tell you, I want to know the limit as x is approaching a number, and then it's going to give you the function. So basically what it wants you to do is it wants to know, what are my y values approaching? When I say limit, I'm thinking to myself, what are my y values approaching as x is approaching this specific case? In this case, this is 0. Okay, and there's lots of different strategies to kind of look at this. What we're going to look at today is we're going to look at kind of just plug and chugging and finding the limit that way by plugging in points and figuring out what y values are approaching as x is approaching 0. And we're also going to be looking at some graphs and seeing what's the limit as we look at some graphs of functions. So the first two examples, what we're just going to kind of look at is we're just going to look at kind of the grunt work of this, plugging it in a calculator and literally saying, as I pick x values that are approaching 0, what does it look like my y value is approaching? That's kind of what a limit means. So for the first two, we're just going to make a table like this, and f of x, which is the same thing as y. And what we're looking at is I'm choosing values. So I'm going to start, I want to approach 0. Now I don't necessarily care what my values look like at 0, and that's a little confusing. I think the graph will help with that. So I want to know, what does my y values approach as my x values are approaching 0. So I'm going to start with 0 in the middle, and I kind of think to myself, okay, I'm going to approach 0. So if I start with a -0.01, as I get closer to 0, the numbers are going to get smaller and smaller. So -0.001 and -0.0001. So what I'm literally saying, I'm approaching 0 from the left, negative value. So -0.01, -0.001, -0.0001. Now it doesn't really matter which x values you choose, but the smaller the x values you choose, we're choosing pretty small x values, the easier it's going to be to see what y is approaching. And I'm going to do the same thing for my right side as I did for the left side. That should be 0.01. So what I'm literally doing here is I'm literally saying, okay, I'm choosing x values, and I want to know, what does it look like my y values are approaching as my x values are going from -0.01 to -0.001 for -0.0001. And what we're looking at is we're looking at what are these y values approaching as I go towards 1. So we're not necessarily looking left to right. We're kind of working my way towards 0 as x is approaching 0. So if we just plug this in our calculator, if you just want to kind of all plug it in at once, you can do that. So we're going to have -0.01 divided by, overuse parentheses more than you need to necessarily to make sure you don't do order of operations wrong, square root of -0.01 plus 1. This parenthesis ends the square roots, and then minus 1. And I think I'm going to need another parenthesis in there. No, I think I made a mistake. It should be a plus 1, parenthesis, minus 1, parenthesis. I think this is correct. So as I look at this, the parentheses are kind of confusing sometimes. -0.01 divided by, I need a parenthesis because I have a binomial on the denominator, so the denominator encompasses more than just the square root. Parenthesis, square root, this is the part under the square root, parenthesis ends the square root, minus 1, parenthesis ends the denominator. And that gives me 1.99499. 0.99499. Okay? And we're just going to keep doing it. I'll do it for a couple more. Plug in -0.001. So if I plug in -0.001, we'll do that real quick, and then I won't do much of the other ones with you. divided by square root negative 0.001 plus 1 parenthesis minus 1 parenthesis 1.99950. Now, I'm not going to do the rest of you when I plug them in, but as I go through them and plug the rest of them in my calculator, we're going to get a 1.99995. 0, you can do in your head if I plug in a 0. We're going to end up getting now, as I look at this, if I try plugging in a 0, I notice I'm going to get a 0 because I have a 0 over 0 in the denominator. So I can't really, if I try to plug in 0 like I've been doing, I'm going to get the square root of 1 minus 1. I'm going to get 0 in the denominator, so that's not going to work. So be careful. What limit means is I want to know what is the y value as x approaches 0, not necessarily at 0. And that's going to be important. So we're not necessarily worried about what is the y value at 0. We want to know what is the y value as x is approaching 0. And as I go through and plug in 0.001 and the positives over here, I end up with a 2.00005, a 2.00005, and a 2.00499. Now as I look at this, you can literally see, as I go from the left and the right, you see that my x values seem to be approaching 2. I'm approaching 2 from the left, I'm approaching 2 from the right, I'm getting closer and closer to 2. So the limit, as I kind of approximate this, is I'm approximating that my limit as x is approaching 0 to be close to 2. And that is using just plug and chug, looking at different points. Let's do the same thing for example 2. It looks a little more complicated. The only thing that's going to make it complicated is plugging it in your calculator, and I'll look at a couple of those instances with you. Now be careful, this is as x is approaching 3. So if I kind of make my table, this is x is approaching 3. Not necessarily when x is 3, because if you notice at your function already, if I try to plug in 3, I'm going to get a no solution. I can't just plug in a 3. So it's not necessarily what is the y value when x is 3, because that would be just as simple as plugging it in. This is the x value as y is approaching 3. So let's go ahead. We're going to go 2.9. We're going to get closer and closer to 3. 2.9, 2.99, 2.999. Like I said, I'm using really kind of teeny tiny intervals here. I could use like 0, 1, 2, but it's easier to see what it's approaching if I pick smaller intervals like this. And then I'm going to choose 3.1, 3.01, and 3.001. So I'm approaching 3 from the left, 2.9, 2.99, 2.999, and I'm approaching from the right, 3.001, 3.01, 3.1. So I'm slowly getting closer and closer to 3. So as I plug this in your calculator, let me just show you how to do it once real quick, and then I won't do it for the rest of them. So if I look up here at the top, I have 1 parenthesis, 1 divided by, now make sure you put parentheses for the denominator, 2.9 plus 1, double parenthesis, minus 1/4. Now if you want to go ahead and get that answer, and then if you just click the dividing problem, it's going to take your answer you just got, and I want to divide it by x minus 3. So I'm going to divide it by 2.9 minus 3. And that will give me a negative 0.0641. Now as I go through and do the same thing, plug in the rest of these numbers, I'm going to get a negative 0.0627, a negative 0.0625. So if you want to try a couple of these to make sure you're getting them. 3.001, I get a negative 0.0625. 3.01, negative 0.0623, and a negative 0.0610. So as I'm looking at this, my y values seem to be approaching as I go from the left towards 3 and to the right towards 3. They both seem to be approaching relatively close to negative 0.0625. Now this isn't going to be exact necessarily, but you can get a pretty good idea. Now if you want to go ahead and graph this, you can always graph this on Desmos or on your graphing calculator and see that, okay, it does look like it's approaching that number. For example, if I go back to example 1, if I graph this real quick, let's just do this real quick. I have x divided by the square root of x plus 1 minus 1, and I graph that. I should notice, once this gets graphed, maybe, let's do zoom standard. I don't know why it's not graphing. I don't know. Anyway, if you would graph this or graph this on Desmos, you will see that as x is approaching 3 or x is approaching 0, that my y value will be approaching 2. So you can always check it on Desmos if you're not sure. I'm not sure why it's not graphing. That's okay. It's frozen now. Okay, so let's go ahead and look at example 3. Now we're going to look at finding a limit. So if I notice, we're going to be looking at a graph, and I want to know find the limit of f of x as x approaches 2. So I literally just wrote out the limit, what a limit means. Find the limit of f of x or y as x approaches 2, where f of x equals 1 and x cannot equal 2, and f of x equals 0 and x equals 2. Now this is a piecewise function, which you've seen before. So basically if I have f of x, if it helps you to rewrite it, f of x equals 1 basically is just y equals 1, and that's just a straight line. But I know x cannot equal 2. So that line, y equals 1, exists everywhere except when x is 2. And then the bottom one, I basically just have y equals 0, and that exists when x is 2. So if I'm graphing y equals 1 and y equals 0, those are just going to be straight horizontal lines. So if I graph y equals 1, that line exists, except x cannot be 2. So where x is 2, that line does not exist. So this here on the right is how I graph the function y equals 1, except x cannot equal 2. So I put an open circle where x. Basically, they just give me the second
one is just an ordered pair. When x is 2, y is 0. So I'm just going to have a point right there. And what I want to know is I want to know find the limit of f of x or y as x approaches 2. Now this is like we said before. As x approaches 2, it doesn't necessarily mean when x is 2. But as x approaches 2, it looks like my y value is approaching 1. So as I come from the left and I come from the right, as I'm approaching 2, not at 2, as I'm approaching 2, it looks like both sides are approaching 1. So my limit would be 1. And that brings up another key point. The left side and the right side for the limit have to be both approaching the same thing. And we'll talk in a couple of days about left limit and right limits, where they don't necessarily have to be the same thing. But for today, unless they specifically say the limit from the left or the limit from the right, which we'll get to in a little bit in a couple of days, they both, left and right, have to be approaching the same thing. Okay? Let's go ahead and look at example 4. If I look at example 4, now it actually writes out the limit. The limit as x is approaching 1 of f of x. So I want to know what is my limit, what is the y values approaching as x is approaching 1. And they tell you f of x, this is a piecewise function. X squared plus 3, x cannot equal 1, and basically I just have y equals x squared plus 3 and y equals 2. So x squared plus 3, you should be able to look at that and figure out pretty well what that's going to be. That's going to be a parabola with the transformation up 3. 1, 2, 3. So negative 1, if I plug, you can plug in a couple points if you want to. Negative 1 will be 4, 1 will be 4. But be careful, x cannot equal 1. So this parabola exists everywhere except x cannot be 1. So that will be, I have an open circle when x is 1 and something like that. Okay, so we're graphing a quadratic, so I'm going to have a parabola. This exists everywhere except they tell me x cannot be equal to 1. Then they tell me that y, or f of x, equals 2. So y equals 2 when x is 1. So basically that's an ordered pair. So at 1, my y value is going to be 2. That's a filled-in circle, similar to the one we just did. Now I want to know the limit as x approaches 1. Not necessarily what is the y value when x is 1. I want to know what does it look like my y value is approaching as x goes to 1 from the left and from the right. So as I look at my graph, as I zoom in a little bit, from the left I go down and I go up, so it looks like I'm approaching a y value of 4. And from the right I'm coming down and it looks like I'm also approaching a y value of 4. So that limit would just be 4. Okay, let's look at a couple more using graphs. Okay, so let's go ahead and look at example 5. Limits that fail to exist. So these, example 5, 6, 7, these are some instances where limits don't necessarily exist. Okay, and we'll be able to look at a graph as we kind of investigate the graph, why that limit doesn't exist. Now, as I look at graphing this, you're going to look at this and you're going to be like, okay, I see absolute value. I kind of know how to do absolute value. It kind of looks like the v, but then I'm dividing by x. I don't really know how to do that. Let's kind of think about this. So let's kind of split this up. The absolute value of x, kind of remember what the definition of the absolute value means. If I think about absolute value has a negative part and a positive part to it. So as I kind of think what the definition of the absolute value is distance from 0. So what this is saying is I have a distance of x from 0. Let's think about a 5. If I would think of a number line, and let's say I have a distance of 5 from 0. What two numbers are a distance of 5 from 0? Negative 5 and 5. So what two values have a distance of x from 0? X and negative x. Now this exists. This is a positive x when x is greater than or equal to 0. And this is a negative x when x is less than 0. So it's positive x if I have positive numbers including 0. X is greater than or equal to 0. And then I have a negative x when x is less than 0. Now, if I just look at my function, I say, well, it can't be 0 because it'll give me a 0 in the denominator. I'm not worried about that yet. All I'm kind of looking at is this absolute value of x part. Now, I'm going to be worried about the absolute value of x over x, and that's our function. So now I'm going to take what I looked at with the absolute value of x, the x and the negative x part, and now I'm going to put it over x. So now I divided by x, so I'm going to have x over x, and x over x is just 1, so it just becomes 1. And I have negative x divided by x. So I know it's kind of weird, but what we're doing is we're taking my function of the absolute value of x, which is the x part and the negative x. I'm dividing by x. So x divided by x gives me 1. Negative x divided by x gives me negative 1. And this is going to be 1 when x is greater than 0. Now be careful now. It can't be equal to 0 anymore because I'm dividing by the x. And when x is less than 0. So that's how we kind of think about how do I graph this. Think about it as separate piecewise. So now as I go to graph this, I have f of x equals 1 and f of x equals negative 1. And we graphed that earlier. So if I have f of x equals 1, that basically means y is 1 when x values are greater than 0. So I go to where x is 0. Y equals 1 is just a horizontal line across y equals 1, but that line only exists for x values that are greater than 0. If I graph a negative 1, that's going to be a horizontal line, y equals negative 1. That only exists when x is less than 0. So open circle at 1 to the left.
So as I look back at my limit, I want to know my limit as x approaches 0, from the left and from the right. We have to include both of those. As I look at it, from the left, it looks like my y value is approaching, well, it's going to be -1 because it's -1 the whole time. And from the right, it looks like I'm approaching 1, which is basically the whole time. So like I said earlier, this does not exist, so D and E is how you might see it in the book. This limit does not exist because the left and right are not equal. The left and right limit have to be equal for the limit to exist. We'll talk in a couple days about when they wouldn't have to, if I'm just looking at the left or if I'm just looking at the right. But in general, this is from a general limit, is from the left and the right have to be approaching the same thing, which they don't in this case. Okay, example 6. So that's one case where a limit does not exist, if it's the left and the right do not approach the same thing. Example 6. Discuss the existence of the limit as x approaches 0 of 1 over x squared. So this might not be a parent function that you're super familiar with, but you can kind of just think about plugging in points real quick. 1 over x squared. First of all, I know I cannot be at 0, because if I plug in a 0, it's undefined. If I plug in a -1, it's going to give me 1 over 1, so 1. If I plug in a -2, that's going to give me a 1/4. If I plug in a -3, that's going to give me a 1/9. So you notice it's going to be approaching 0 down here. If I plug in a half, so 1 over 1/2 squared is 1 over a 4th, which dividing by the fraction is the same as multiplying by the reciprocal, so that's just 4. So 1/2 is going to be 4. So you'll notice it's going to look something like that. And the same thing if I plug in negative or positive numbers. It's going to look something like that. So as I look at this, I want to know what is the limit as x approaches 0. So as x approaches 0, from the left and from the right, what we notice is that they are going to infinity. So they're not, the left is going to infinity, the right is going to infinity, so they're not really approaching anything. So limit does not exist because left and right are approaching positive infinity. So they're not actually approaching an actual number. Even though they're approaching the same thing, an actual limit needs to be a specific number. And the last case, if I look at example 7, discuss the existence of the limit as x approaches 0 of sine of 1 over x. Okay? So let's go ahead and try some things real quick. Let's check kind of like we did the first couple examples where I plug in some x values and see what I have. And then I want to know what I get back. So sine of 1 over x, which is the same as having f of x there. Same thing, I'm just putting the function. So let's say if I plug in, let's check. I want to know sine of, what I know is that if I look at my unit circle, I know sine of pi over 2. So if I'm thinking easy ones on the unit circle, sine of pi over 2, so if you have your pink sheet out. So as I look at my unit circle, I can do pi over 2 pretty easy. I can do 3 pi over 2. Okay, as I kind of look at ones to kind of try, let's try those easy ones. Now I want to know as I'm approaching 0, so I want my x values to be getting closer and closer to 0. Okay? So as I look at this, we have, one second. So what we're going to check first is I'm going to go ahead and check. I'm going to plug in 2 over pi for x. Now it looks kind of weird why I'm choosing 2 over pi, but let's think about this. I want sine of 1 over x. So if I plug in 2 over pi in for x, 1 divided by 2 over pi is the same as pi over 2. And I know sine of pi over 2 from the unit circle. So sine of pi over 2, sine as the y value, is 1. So that's just 1. The next one I'm going to check is 2 over 3 pi. Now you'll notice my x values are approaching 0, so if you'd actually divide them out, it'd be easier to see that I'm actually approaching 0. 2 over 3 pi, which if I do 1 over 2 over 3 pi is the same as 3 pi over 2 because I flip it. So 3 pi over 2, sine of 3 pi over 2 is -1.